En nombre de la Sociedad de Criadores de Angus, les damos la bienvenida y muchas gracias por acompañar esta iniciativa de esta conferencia técnica que estamos haciendo hoy a cargo del doctor Moser. Queremos agradecer la presencia del equipo de INIA, Olga Rabagnolo y bueno, todo su equipo. Queremos también agradecerle a Genexa, al equipo de Genexa, Rosina Fossati, Andrés Pereira y Carlos Azambulla, que nos están acompañando en esta actividad. También a la ingeniera María Noel Reisic, responsable de Genómica para el Cono Sur de Neogen, que son los dos auspiciantes de esta charla. También quiero destacar la presencia de Daniel Gianola, genetista uruguayo reconocido a nivel mundial, que también nos está acompañando hoy. Y bueno, antes de hacer la presentación del doctor Moser, quería comentarles que estamos trabajando con él hace 1 año y medio en la Comisión Técnica de Angus Uruguay, se sumó al equipo. La verdad que estamos muy contentos con un aporte valioso porque no solo tiene un gran conocimiento técnico, sino que además fue 6 años responsable del área genética del American Angus, que eso de alguna manera es un plus porque ha tenido contacto con criadores que también digamos, nos hace el aporte valioso de cosas que a veces pensamos y él nos comenta qué tan viable es llevar adelante ciertas acciones con los criadores de acuerdo a la experiencia que han tenido. Es decir, no es solo un académico, sino que además ha tenido la experiencia de trabajar en una sociedad de criadores y eso sin duda para nosotros es un plus. Voy a presentar su currículum. El doctor Moser es profesor y decano asociado del programa académico en la Facultad de Agricultura de Kansas State University, una de las 10 mejores universidades de agricultura en los Estados Unidos. Moser fue anteriormente el presidente de Angus Genetics Inc. y director del programa de performance de la Asociación Americana de Angus. Como tal, gestionó programas de evaluación genética, servicios de pruebas genómicas, iniciativas de investigación, actividades comerciales y esfuerzos de educación de los miembros de AGI y la Asociación Angus. Durante 20 años, como miembro del cuerpo docente de la Universidad de Georgia, la Universidad de Nebraska, Lincoln y la de Kansas State University impartió cursos de manejo, genética y cría de animales. Al final de la charla vamos a hacer una ronda de preguntas para todos los que estén interesados. Así que bueno, gracias de nuevo por acompañarnos y le damos la bienvenida a Dan Moser. Muchas gracias.
Gracias, Diego. It is a pleasure for me to be here. I first must apologize. I speak no Spanish. I am grateful for the translator. Thank you so much for your help. I hope you will make me sound more intelligent than I am. I know you will. I trust you will do that. But thank you for your assistance. I grew up in a small town, in a farming town in Kansas, and went to a small high school when I was 15, 16. We had a good teacher that taught languages. She taught French and German. And I have regrets. I have regrets that she didn't retire so that we could hire a teacher that could help me learn Spanish. But I was not so fortunate. My children are much more fortunate in that they have been able to learn Spanish and to, in some cases, go on study abroad trips with Spanish teachers. My daughter will go to Peru next year for an experience to work on Spanish. And so someday, I hope, a next generation, and I know in your country, very impressed with many of the young people that speak English so fluently. It's been, I think the communication in the future will be even better than it is today, but I do apologize for that. I want to introduce a special guest, Miss Reed Middleton. I'll put her on the spot. She is a student at my university, at Kansas State University, in agricultural economics, and she is here on a semester study abroad at a university in Montevideo, and she was kind enough to come along and experience more of agriculture in Uruguay and in the livestock production, and so it's a treat to have her along. So please welcome Reed. Great to have you here. I will talk a little bit about some of the selection tools that are available now, but more than anything, I hope this generates conversation and questions that you have about the technology, and there are no such thing as a question that is not intelligent. All questions are welcome. We all are learning. We are all students, and so feel free, to ask questions. To start off with, I think that it's important to understand, and you understand that you are in agricultural production, that it is a puzzle, and that there are many components, many pieces. I describe it as a puzzle, and that you have to have pieces that fit, and every piece has to fit every other piece in the right order, in the right position, and this piece doesn't fit every piece. If you have this piece, then you have to find the other pieces that match it. And that is, in my mind, beef production. That genetics is a piece, nutrition is a piece, marketing is a piece, grass farming is a piece, health is a piece, and they all have to fit together. They all have to work together, and they all interact. And that the key is to find the genetics that work with the nutrition, that work with the marketing, that work with the grass, that works with the health. It's complex. And so, but those are things to keep in mind. And I know that I've really enjoyed the last couple of days touring, visiting some excellent ranches, farms, operations, and learning about your production system. And it is very interesting to me. And I think there are some things that I will take home. I'm ready to go home and start building fence and starting more rotational grazing at home. And I think that I have neighbors that should as well, because I think that you are better grass farmers than we are, quite honestly. And we have a lot to learn from you in that area. But that's one piece of the puzzle. Now, I'm a geneticist, and so I think the most important piece is genetics. And if you're a nutritionist, you may think nutrition is the most important piece, but genetics is what I was asked to talk about today. And one of the things that I think is important to remember about genetics is that genetics changes are largely permanent. That when you change the population, and that, I notice I didn't say improvement, I said change. And so some change is improvement, some change is not improvement. But when you change the population, then that persists. It remains. It goes on to the next generation. If you change your supplement, when you stop doing that, it goes away. If you have an excellent health protocol, and then you stop doing that, it goes away. If you have a great grazing program, and you stop doing it, it goes away. But genetics persists. Now, you can continue to advance, or you can stay still, you can stop, but it doesn't go backwards. And so there's value in genetics and in selection. And I know we're at a time right now, we're fortunate that the cattle business in this country and in many countries in the world is very good. Profitability is good, and that is a good time to make investment in genetics. And those investments can help you, because it all goes in cycles, right? We've all seen it, and it hopefully not for a long time, but it all goes in cycles. And to build the genetics while the opportunity is now, and that will get you through when there are some tougher times. I also want to congratulate the Uruguayan Angus Society. It's been really fun for me to work with this group, get to know them. It's a great success story. The success of the Angus breed in Uruguay is exceptional. And the leadership, the success that you've had, but I remind everyone, and I remind the Angus breeders and the leaders that, with leadership comes responsibility. That I always thought, when I previously worked for the American Angus Association, I thought a lot about what our team was working on and the influence that those decisions had on the United States beef business and on the beef business all over the globe. And you have the same responsibility here. And as Angus assumes a leadership position, a significant part of this nation's economy relies on you. So that is a big responsibility. And I know that you take it very seriously, and that you will do a great job. As I say, you are now in the driver's seat. You are in a position to steer, at least partially steer, this industry. And So, but you have to give it some thought. So now you are in the truck, and you are taking the wheel. Where will you take us? What direction will you take us? That truck can go anywhere. You can drive it to a party. You can drive it to the bank. You can drive it off a cliff. You can drive it into the ocean. But you're now driving, so you have responsibility. So I think it's good to always stop and pause and reflect about where do we want to go? Where does the industry want to go? What drives success and profitability and sustainability for this industry and this nation? Every part of every business, we think about the food business, the global food business, but every business is more and more data driven. That is even the work that I do now. Now I have an administrative role at a large university. And the data that I have at my fingertips to make decisions is far superior to what was available 10 years ago. It used to be if I wanted to know trends in enrollment or trends in faculty productivity and publications and class enrollment, which professors had more students taking their classes and which professors had fewer students taking their classes, that took a lot of work. I'd have to have somebody work on that for a week. Now, click, 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 there it is. And so we have better information to make decisions. And that is true for all aspects, and certainly beef genetics is a great example of that. And so we have opportunities to do things that were just not possible in the past. And we can focus on productivity, we can focus on efficiency, we can focus on environmental impact. That is a more and more important part of our business. One of the things I noticed flying down here, there's now once again a magazine in the airplane. For a long time there was no magazine. Now there's a magazine again. And there was a story in there from a celebrity in the United States. He gives the weather. He gives the weather report on the largest morning news show in the United States. And he's known as a food person, and he's known as someone who is very, pro-meat and that sort of thing. But he talked about environmental concerns and should he be consuming less meat? That's a conversation. And I think we are in a place globally where we need to have information and understand our impact, and we do need to feed more and more people, and people want to have a higher standard of living and a higher diet, a better diet, but we also have to think about all the implications. From a sustainability standpoint, you have an important role to play. That when we think about in my country about sustainability of beef production, some of it is the very large amount of grain that we use in producing beef. We have some calves that spend more days eating grain than they do eat grass. That is not a sustainable system in many ways. There are parts of my own state where we grow very productive corn with less than 500 millimeters of rain. And we do it by pumping water out of the ground. There is an aquifer there that filled up over 1 million years, and we've drawn it down in 50 years. So I think there is much that the rest of the world can learn from you as a leader in grass-based beef production and using grain appropriately and efficiently. But I see a role for your breeders as leaders globally in designing the animal for the system of the future. There will always be, I think, some grain used, but I think it will be less, and I think you have the opportunity to help define for the rest of the world efficiency in that sort of a system. More specifically about genomics, that one of the things that I've really enjoyed, I began studying genetics at the perfect time. I didn't know it when I started, but I had no idea the changes that would happen in the breeding of livestock during the time in my career. And it truly has transformed in many populations, in many species: dairy cattle, beef cattle, poultry, swine, and beyond. Aquaculture, all those areas are very heavily using this technology to make improvement in the populations that they manage and control. And the sort of the bottom line is that it allows us to do things we couldn't do before, to measure more animals for more things at earlier ages with greater accuracy. And so we're just making better decisions. And that's the promise, and I think a promise that has been realized, but I think the potential is even greater in the future. This is a little bit of, for those of you who are familiar with genetic evaluation, with what I would call EPDs, you would call DEPs. And this is from the American Angus evaluation, and just an example that we often use to show the difference that a genomic evaluation can make. This is from a very young animal, and some of you may be familiar with these values, and some may not. These are measures of growth, early growth, birth weight, weaning weight, yearling weight. And then we have some information about efficiency here, but you can see that in this animal this is missing because we don't know. We have some information about carcass, but the accuracy is the second number. The accuracy is very low. The accuracy here is very low. This is an animal, a very young animal, an animal that was produced by embryo transfer, and so we don't have a record for this animal to evaluate. We just have a pedigree, and that's all we have. But we can test an animal with genomics, and we can learn a lot more about this particular animal. First, in the area of growth, we have much more accuracy. Now, as we add records to the animal, accuracy will continue to increase, but the accuracy of prediction, the knowledge that you have on this animal is greatly enhanced by having a genomic information in the evaluation. We have some traits that are very difficult to measure. This is feed intake, dry matter intake, feed consumption. And that is an important trait. That is an important trait in all systems. It is important in forage systems. It is important in grain systems. It is difficult to measure. It is expensive to measure. And there's great research happening here and all over the world to understand that. But we can measure a limited number of animals. We'll never be able to probably measure every animal for those traits. But we can practice selection on many animals. In the United States, they would have maybe 10,000 animals, which is a lot, but not compared to 300,000 a year that are registered. And so, but they are able to take that information, and with genomics, we can extend the knowledge to many more animals. And so we can make change and selection through genomics, even though we measure the right animals, we measure enough animals, we invest in that technology and in the data, but then we extend it to everyone. And they can, even if you can't have a feed intake system, but you can still make progress. And it's amazing how it's changed the population. But before we evaluated that, in our country, growth is going up dramatically, marbling is going up dramatically. Those things aren't free. And as a result, feed consumption was going up dramatically. But we didn't know because we weren't measuring. When we started measuring and started extending the information, and breeders started using it in selection, now we still have increases in those other traits that in our system we want, but the feed consumption is flat. It's a great story. It's a great story for the rancher. It's a great story for the rancher's banker. It's a great story for the environment too, in terms of what we can do for the efficiency of production, but we couldn't do it without genomics. And I think that in many systems, things like that will come. And then some of these other traits, the increased accuracy at younger ages, that helps producers to make decisions and know more information. There's value there. I like to, I work with farmers and ranchers in many different places, and my dad was a farmer. I kind of act like a farmer. I have a few cows and a small tractor, and I entertain my neighbors who are real farmers. When my little tractor gets stuck, they bring their big tractor and pull me out, and then they go to the coffee shop and laugh about the professor. That's okay. That's okay. It's a good trade for me. But when I talk to farmers and work with farmers, they don't want to just know what, they want to know how. Even though they can no longer fix their truck, they can't adjust the setting on the carburetor anymore. They can't, then they're not going to reprogram the computer that makes it all work anymore. But they still want to know. They want to know a little more. They want to have a little understanding, and with understanding comes trust. And so I like to raise the hood and to point at some things. And I may not be able to tell you everything, and you don't need to know everything. But to maybe raise the hood and talk a little bit about some of the things that how we use genomics to know more about animals. That from the very beginning of selection, there were pedigrees. There were herd books from societies in the UK and other places that go back centuries. That's nothing new. But as we work with pedigrees, and pedigrees are key of any genetic evaluation, that pedigrees are the way we connect animals and share information between animals. So when you have, without genomics, when you have an EPD, a DEP for an animal, it's not just based on that animal's own weight or record, but it's on relatives, it's on half siblings, it's on animals throughout the relationship. And we have always made assumptions, and I know the terminology is probably, I'm sure you have a much better term than abuela materna, but there's probably a better name for that. Did I get that halfway right? That was just a guess. My daughter would be proud. I should have had her help with this. You know what I mean. That is the most important. Bad Spanish is better than no Spanish, right? I hope. We'll see. If you all start laughing at a slide, I'll know that I got it dramatically wrong, and that's okay. But the assumption has always been that the relationship between the father and the calf is 50%. And between the next generation, the grandparent is 25%, and so on. And that is a reasonable average, and without other information, that's really all we can know. But it's striking when we start looking at genomics, we can start understanding those relationships. We can measure those relationships. We can measure the commonality of segments of DNA, of chromosomes. And it's random, and it's not as consistent as what we may have expected or assumed. That, for example, in this pedigree, and this was an example from the evaluation in the United States, this grandam, this grandmother cow, the expectation was 25%. But in this particular animal, when we looked at the genomics, because we had DNA on this cow, and on this cow, and on this calf, it's much more than that. And you say, how can that happen? Well, if you think about this cow makes eggs, okay? She makes eggs, and one of the eggs becomes fertilized to become the calf. But every calf, every egg is a little different, because she is making an egg that has a random half from her father and a random half from her mother. Not all of him, a random half. Not all of her, a random half. And then she makes an egg, and every egg is different, okay? Same way, the father, he makes many sperm cells. Semen straws have millions of sperm cells. They're all slightly different. It's a random segregation. It's a draw. It's a lottery. And many of you have siblings, you brothers and sisters. There's a reason that you are smarter and better looking than they are. That you got a better draw. You are genetically fortunate. And it's the same way with cattle. But with genomics, we can figure that out more easily. If this particular cow is exceptionally good for a trait, if she is moderate in her size relative to growth, if she is inherently efficient, if she is superior in her behavior, disposition, whatever the trait that we're interested in, and we know that there's a greater relationship than average, then the evaluation knows that, and it reflects that in the value. Even here, you'd say, now wait a minute, Dr. Moser, I took biology. How can that be more than 50%? It's not. It is 50% by transmission, but there is, in every breed, and even in animals of different breeds, there is some commonality, some low or not so low levels of inbreeding. And so there's some relationship that this cow contributed, but the bull also had. And so when we say, okay, what percentage of commonality, it's more than 50, everything the bull gave, but a little bit of what the cow gave, the bull has too. And so that increases that relationship. And when we build a pedigree that way, when we build it more precisely, and then we use that in a very much, the rest of it's very, very similar to what we've done before. There's a few little things that you kind of build in there, but that's a big part of how genomics influences evaluation in cattle, in beef cattle, and dairy cattle, and swine, and so on. It's a very common approach, and that is how, you know, that is used in your evaluation. It's used in the evaluation in the United States, actually with similar software, similar approaches. So that's in a nutshell how it works. That's what you see that's what makes the truck go. Now, Americans like to talk about data, and yes, blah, 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 yeah. What I want you to take away from that is you don't have to have 1 million genotypes to have a good evaluation. I know, because when I was at the American Angus Association, we also ran the American Charolais Association evaluation. They were a client. We did their business. We managed their evaluation. They did not have 300,000 genotypes. They had 2,000 genotypes. They were very early on in collecting the data and doing genotyping. They still had an excellent evaluation, and they saw real benefit from that. And so sometimes I think that there are big evaluations, there are small evaluations. Evaluations get better with more data. Evaluations get better with more genotypes. There's no perfect evaluation, but more information is always helpful. But you have a very good, well-constructed, and well-operating evaluation right now, and it will only grow as the amount of data submission and the amount of genotyping increases. Sometimes breeders ask, I got this question at dinner the other night, so if the DNA and the genomics gets better, eventually I can sell my scale. I can turn it into, you know, some sort of yard art or something like that. I can decorate with it. I don't need that anymore. I'm sorry. That is not how it works. That the testing, the genotyping makes the data more important, makes the data more relevant, makes the data more accurate, but it does not make it go away. That the measurement of phenotypes, of birth weights, of 18-month weights, of mature cow weights, those will be important. Measures of scrotal size of bulls, ultrasound measures of animals, those are all, they become more important, and they influence more animals, because when you look at a traditional pedigree, you see some relatives. When you look at the genotypes, you see more relatives, distant relatives in some cases. Anyone do they have 23andMe here? Do anybody do that? I finally broke down and did it. I did it. Yeah, I don't. There's good news and bad news, like always. But it's finding relatives that I did not know I had. And I took that to my mother, and I said, do you know any of these people? Oh, yeah, I recognize some of those names. Yeah, that's your grandmother's cousin so-and-so. Yeah. 2% relationship. Yeah, that adds up about right, you know. It's the same way with cattle. We find that there are some animals, you measure an animal with ultrasound, and there's an animal out there that you would say on paper is not related, but the genotype says, yeah, no, they actually are related. Because if you think about where this breed started, where all breeds started, with a relatively small group of animals, and then it's been expanded from there. But when you go beyond 3 generations, they're a lot more related than you think. And so that information is useful. And we can make better predictions by using that information and connecting the animals more accurately with a DNA test. But we will continue to need to measure those traits, and it will be important to do so. And it also, as I mentioned, gives us an opportunity to measure new traits and do some other things. Everywhere I go, I think it's also important to talk about interactions and how not every environment is the same. And it really depends on the trait. That most of the research would say that the rankings are fairly consistent. That there are some environments that are higher input, some are lower, and most of the research would say that the animals rank pretty consistently. They may not be the same magnitude that we saw in some work with Charolais cattle when the nutrition level was low. We didn't get every pound of weaning weight. But the rankings were still highly accurate. We got every pound of birth weight. We just didn't get every pound of weaning weight. But we got a high percentage of that. But it did depend a little bit on the environment. But if the goal is to find animals that are higher or lower, then the EPDs are going to do that pretty well. There are a few traits that complicate things a little bit. Something like hair coat. If you've used Angus cattle from Canada, from the United States, from Australia, from New Zealand, or even in Argentina, you may have seen differences in hair coat. I've seen them in my own cattle. They exist. They are heritable. They are genetic. There is a difference. And that can play a role. And one of the things that I was really excited about when I was working at the American Angus Association was that's a new trait that they now have an EPD for. They are collecting hair shedding information that breeders will score their cows from completely shed to, it's like 1 to 5. It's very simple. It's very repeatable. It's very heritable. It works pretty well. Jared Decker at the University of Missouri did a really nice project, and we had some collaborators at other universities as well. But that's an example of something new that I think has economic importance, certainly in the United States. Even in North Dakota, nobody wants a hairy cow in the summer. Not even there. And so even in Canada, they want the cows to be slick-haired in their summer. And so that's an example of, but that can complicate things. And so you have to be on the lookout for that. But I think there is some opportunity there to address traits like that. You know, how breeders use it. Some of you may be already using genomic testing. Some of you are doing a little testing. Some of you are thinking about it. Some of you are not thinking about it. But I have some experiences working with breeders and some of their experiences that you might benefit from. It's natural when you are a farmer and you're selling bulls as for your living that you understand there are different markets, and you understand that some of your customers have high expectations and some of your customers have expectations about price. And you oftentimes will manage to that. That's good business. But the thing you have to remember is that with genomic testing, if you pre-select and say, I'm only going to test these certain animals because I think these have the most value, and this bull, you know, I think he's just average, and I don't think the customer will even ask, so I'm not going to spend the money on that. I understand that. But anytime you test, you find new information. They do not all get better. Some get better, some get worse. On average, about 50-50. Some move more than others. But if you only test the best ones, and they move down, you miss out because there's some in the middle that would have moved up if you would have tested them. And so you're hurting yourself. You need to give the ones an opportunity to show their merit. And you will make some discoveries. That there is a calf that you would say, you know, he's just average, but he may be average for a reason that's not fully genetic. And there may be something about his experience, his environment, something individual that happened to him that is not transmissible to the next generation, not heritable, and he deserves more than you may give him credit for, and you may be able to sell him for a premium. You may get a very nice return on the investment by testing that bull. The other place that we see our breeders and breeders in many countries and in many breeds is testing females. And that's not for marketing, that's for your own knowledge, for your decision making as a breeder to know more and to not assume too much about a young female based on her pedigree. That you would say, well, I have these 5, and they're 3/4 sisters. They have the same sire. Their mothers have the same sire. Their numbers are about the same. Their EPDs are about the same. And then you test them with genomics, and you find out that they're different. And if you didn't have that information, you'd say, well, I think this family of heifers, they're really good on calving ease, but I'm worried about mature cow size, so I'm going to mate them in a way to adjust for that, to correct for that. But when you get the genomics back, you find that on some of those heifers you were exactly right, and then sometimes you get a little surprise. And you say, well, this heifer is actually a little better for this one trait than I might have thought, but she's also not quite as good for this other trait as I might have thought. And now I'm going to breed her differently. Now, you may have found that out eventually after 10 calves. You would have found out eventually if you had her in the herd that long, but you can know much sooner. And you can make better matings, and you can match her characteristics, her strengths and her weaknesses with the bull that offsets those or matches those and helps you achieve your goals and help you produce a product, a bull that your customer wants to buy. I think in this country you've done a good job of focusing on the national genetic evaluation. We did not have as great an experience at the start in my country, that there was information that was genomics only and genomic ratings that were separate from the national evaluation. And it was very clear, as it's always been clear, that you get better information when you put it all together than if you look at the pieces. You've known for a long time that the EPD with the calf's measurement, the calf's own birth weight, plus the sire's information, the dam's information, the birth weight EPD is more predictive than the actual birth weight. One piece alone is not as good as all the pieces together. And genomics is the same way. It adds information, but there's nothing magic about that alone. It's a piece. And so you'll be much more successful when you put it all together and you have a national evaluation that does just that. But just as we wouldn't want you to overly focus on the actual birth weight, we wouldn't want you to focus overly on just the genomic piece alone and the prediction that comes from there. Use it all together and use the best number. This is an example of what is possible, and this is a complicated slide, and I'll try to explain it, and I'll do just an average job. And some of you may have questions about it, and I'll be happy to talk about that later on. But this is, people ask, so how much? How much better? How much more accurate? How do you put that in perspective in terms of what you learn from genomics? And this is, again, this is from American Angus. Most other evaluations, the numbers would be smaller. The numbers used to be smaller in American Angus as well. But what this says is there are a couple of ways that we can learn about an animal. We can learn from a progeny test. We can learn from genomics. And so this is how big a progeny test would tell us the same thing. So we would get the same accuracy if we had nothing else but genomics for birth weight, that the accuracy that we would get in the evaluation is the same as if we had no genomics, but we had 23 calves. And that's a lot. That is a lot. If you have a bull and you have 23 calves from him that have been weighed, and you have other calves in the group that from a proven sire that you're comparing them to, then you have significant knowledge there. And that is the degree of knowledge that you can gain from a genomic test. A trait like milk EPD, it's a very high number. It's a high number not because the genomics are amazing, it's because the data is not as powerful, because the trait is less heritable, the trait is more environment, the trait is more variable. It takes more daughters to know a bull for milk than it does to know for birth weight. And so in this case, what you learn about the milk production of a bull, a young bull, a bull calf, about his daughter's potential for milk, the level of milk, whether you want more, less, or in the middle, but your description of him. It's really, I think when we called it evaluation, we chose the wrong term. We should have called it description. That is really, I think, more what we're doing. We're describing the level of traits of cattle, but you know as much as you would if you had 36 of his daughters that had weaned calves, and that information had been used in the evaluation. And that's a lot, and that takes time, and that takes money. And if you have those 36 daughters, and then you find out it's not what you want, you still got those 36 daughters. And you can sell them or you can do something with them. But if you do with genomics and you learn and so you don't use that bull and you don't get 36 daughters, that might be good too, to know whether you know it's just what you want or whether it's that you know what you don't want. New traits. That there are some things that are difficult to measure. We talked about feed consumption and feed efficiency, and that is important, but it is expensive. Tenderness of meat is a perfect example. It is a perfect trait for genomic selection. It is very expensive to measure meat for tenderness. You have to get the steaks, you have to cook them. There's a very complicated process to get uniform results. You take a steak and you drill 8 holes in it and you make cores and you cut them and with a machine. It's crazy. I used to do it in research. It's a pain. But it's heritable and it makes a difference to a consumer. If you had a tough steak, the risotto was tough, you may not tell the waiter, but you will tell your friends, right? I'm not going back there. It was not good. And we can fix that, and we have fixed that in some breeds, and we can fix it in more. And we want to make sure, even in breeds like Angus, where tenderness is generally really good, but we don't measure every one, and there are some that are not so good. And we want to be sure that we are maintaining our expectations and meeting our consumers' demands and adding value, because it doesn't cost any more to feed a tender one than it does to feed a tough one. So you might as well feed a tender one if you can find them. Where do you start? Some of you, again, are doing testing, but even if you're not testing, think about sampling. Think about sampling. That we have many breeders that will take a tissue sample when they tag a calf. You don't have to test every one. You don't have to test any of them. But you can't test if you don't have a sample. And you don't want to have to get them back in to test them, to sample them. So just go ahead and get a sample. It doesn't cost very much for a sample. You can store it. You can store it in your office. You don't have to freeze it. You don't have, depending on if you have the tissue sampling units, there's different companies that make those now. Do not store them on the dashboard of your truck. If you store them there, they will not work. Don't do that. But if you store them in an office, it can be good for a long time. And you may find there's value. You may not know. Okay, I don't know if this calf is going to have value or not. I may not know for 6 months. I may not know for 12 months. I may not know for 2 years. But if you have the sample, then you can test them. You can decide. And some of the animals, you say, yes, I want to know more on these. These I don't care about. I don't have to send those in. But you don't have to. The cost of gathering the cattle may be more than the sampling. You decide. I'll wrap up and answer some questions. Happy to have a conversation on staying for dinner and for the auction, and be glad to visit with you individually. I'll provide my email. You can always reach out to me. This has been a great pleasure for me to work with the Angus Society, to work with your breeders, to work with your staff, to work with the folks in research here in Inya and other places. Uruguay is the best kept secret in the world. I'm sorry to tell you, there was a story in the Wall Street Journal about 6 months ago, and it was, Uruguay is amazing. I hope all the Americans don't come. You don't want them. I hope they stay there. Because I want to be able to come and enjoy it without all them here. But it is an amazing place. People say, when I meet people and I'm telling them where I'm going and I'm working with, and they say, tell me about Uruguay, I say ranches and beaches. It is no better than that. And asada. That's the three. the Trinity. And so I've really enjoyed my time here. It has been fun to learn as well as teach. I look forward to my next visit and many conversations before then. Thank you for the time, the invitation, your attention, and I would welcome some questions.
Hola. Bueno, quedan espacio abierto para preguntas. Si alguien quiere arrancar. no lo vamos a despedir a Dan. Doc.
Buenas noches. La pregunta a Dan sería, considerando nuestro sistema pastoril o el foco que se hace en la parte de cría en el sistema pastoril, ¿cómo piensa él que podemos ganar terreno en mejorar la aptitud de nuestras vacas usando la genómica?
Yeah, thank you, Lucas. It is a different system, but I think that some of the things that matter, traits matter. They're just different, and I think the important thing is you define your goals in your system. What traits are priorities, and there are some traits in other countries that are very high priorities that are not priorities here. There are some traits that are priorities here that are not in other places. That, for example, moderate cow size, fleshing ability, reproduction, all those things are more important. They're important everywhere, but it depends on what is the cost of compensation for that. And some places can compensate for that better than others. And they're all profitable. Depends on the system. But I think that all those things are things that you want to know. And it is, for example, to know on a young female a more accurate prediction of her mature size. And whatever your goal is there, that if you can know that with more certainty, you can make some projections based on her early growth. You can make some projections based on her pedigree. But if you can add a genomic profile to that, you can know that trait with more certainty. And you can also know, when you sell a bull to your best customer from that cow, what are his cows going to look like? That's more important. That's your reputation, that's your business, that's your customer. And so for a trait like that to have more certainty, I think is very important. Reproduction is a trait that I think is a priority in evaluation everywhere. And some countries and some breeds have farther along than others. The American Angus Association is one of the worst in collecting reproductive data. 6 years I could not convince them. Some blue in the face. But they are starting to make progress. Maybe once I left, maybe that's all it took. Kelly is doing an excellent job. But that is something. It's not easy. It's not easy to get started. It's a complicated trait. But if you are submitting, you all submit which cows stay, which cows go, which cows are pregnant, which cows are not pregnant. Simple, and there is genetics in that. And if you can't just, you have to accumulate lots of data. But when you accumulate the data, you can make a meaningful prediction, and you can improve your herd, and you can improve your customer's herd. So I think that regardless of the priorities, that it's about more accurate description of the animals and taking away, there is always uncertainty. There's always uncertainty in business. There's always uncertainty in young animals. But we can reduce that, and you can be more certain and I think be more successful. That's an excellent question, Lucas. Thank you.
Gracias, Dan. ¿Alguna otra pregunta?
El de camisa blanca. Hola. Bueno, gracias por la presentación, doctor. Tengo claro que la población de referencia cuando un país va a hacer análisis genómico es muy importante. La duda mía es si la población de referencia que nosotros tomamos tiene la misma influencia en todas las características del EPD, o hay algunas características que son más independientes de la población de referencia.
Yes, thank you. The idea of reference population, it's a little bit different now with our new methodology. You know, there was a time when early genomic prediction, that there was sort of these multiple steps. You would estimate the effects of markers and all that, and it was really important to have a population, a wide distribution of animals across the population and phenotypes and all that sort of thing, or you could get some extreme predictions, and predictions were unstable, and I saw that in the old system, and why I was so happy when we implemented the new system, even though the new system was a big change, but I knew it was the last big change because it was a much more stable system, and it is not as dependent because it works through pedigrees. And so it is helpful to have animals that are sampled, but it will not over-predict animals that are outside the group. The old system would. It would clearly. If there were animals that were unmeasured, animals that were unrelated, and they were tested for the first time, it was like it was forced to make a prediction. The new system that is used here and used everywhere now is a system that is conservative when animals are outside. You know, if they're new bloodlines, if they're unmeasured for traits, those sort of things. It will tend to not move the animals very much because there's not much knowledge there, but it moves it the right amount for what we know. And then over time, as more animals are tested in those families or for those traits, then the impact of genomics will grow appropriately, but it will not over-predict animals early. And so I think that if there is a family that is untested within this breed or any breed, and you know, when you first start testing, what you'll notice is not a lot of change. But that's okay, because we don't know a lot. And then as more testing happens and more data collection happens, then you see the appropriate impact, the weighting of genomics on, but you know, the animals, you know, it goes back to redefining that pedigree. And when you say, okay, this animal is unrelated, or at least no one is unrelated. They're all related to some extent, but they're related less. And so what they do is they just stay put. And that's okay. That's what they should do until we know more. So I think this is a system that is safer, it is more unbiased, and it will allow growth gradually as it should, and you will not get dramatic surprises. Thank you for the question.
Buenas noches. Yo quería preguntarle si la precocidad reproductiva en una vaquillona indicaría que va a ser una vaca fértil a lo largo de toda su vida, o más fértil que las demás del mismo grupo.
The question asks about early puberty and its relationship with lifetime fertility. And like, you know, I'm a university professor, so I will say it depends. But the thing that you have to think about is that it has a role. It depends on the breeding system and the length of the breeding exposure period and things like that. You know, we tend to breed heifers very early. And so a heifer that has early puberty, you know, in our system, she may have 3 heats within the breeding season, and so she has 3 chances. If she is later in puberty in the breeding season, she may has 1 chance. Okay? So in that way, she is by definition less fertile because she has fewer opportunities. And then when you carry that over in a fixed breeding season, a fixed calving season, when you calve for a fixed period of time, whether it's 45 days or 120 days or whatever your period is, the cow that calves last has fewer chances the next time. And the cow that calves first has more chances, okay? So in that way, early puberty does carry over. But I don't think there's strong evidence that on an individual conception that a heifer that is earlier in puberty will have a higher conception rate on a single service. So I think, do you understand what I'm saying? That it has to do with opportunities, it has to do with timing. If you left the bulls in year-round, I don't think you would see a higher pregnancy rate in the early puberty than the late. I think it has to do with fixed breeding and fixed calving, which is great, but it's about, you know, the group of cattle that you're managing, and are they cycling at the same time? Or can they be bred at the same time? Or when they're late, it's hard to get them moved back up. And so I think is the research would say that there's not, early puberty is not, you know, is going to dramatically improve, you know, say conception rate of one service. Does it make sense? Yes, thank you. Excellent question.
¿Alguna otra?
Bueno, primero que nada, buenas noches. Bueno, mi consulta, citando lo que usted comenta, que el primer paso para entrar en todo esto es recolectar muestras de animales para poder predecir sobre poblaciones más generales, ¿verdad? Entonces, mencionó el ejemplo en Estados Unidos que se le extraen muestras de ADN al ternero recién nacido. Luego la muestra, ¿se vuelve a sacar cuando ya crece o es única?
Yeah, the question was about do we resample, and generally no. That there will be a time when we need to resample an animal. The lab procedures are very, very good, but it is not 100%. There will be animals, there will be samples that are not perfect. I used to see samples come in. We had a collection of bad samples, you know, that they was supposed to be a drop of blood this big, and it was a pin drop. You know, we can't work with that. And so we need to resample that animal. We get a tissue sample, and there's no tissue. It just closed, but I don't know what happened. If there was already a hole in the ear, what happened? But it happens, you know. But short of that, if there is a good sample, there is no need for a second sample. The second sample will give you the same result.
Bueno, otra pregunta. ¿Se puede llegar a los mismos resultados de marbling con genética y pasto que con alimentación a grano?
So when you say the same result, do you mean the same phenotype, the same steak, or do you mean revealing genetics? You mean the outcome of the steak? Yeah, I'm not a meat scientist, and so that's the first disclaimer. And there may be experts from the Angus Uruguay beef program that may want to comment on that, or others that are more knowledgeable. That marbling is developed through in genetics and nutrition, just like everything. It depends on the grain, it depends on the grass. You know, you can, there are some grass-fed cattle that have excellent genetics and can have high degrees of marbling, but there is a threshold of energy that has to be provided. One thing I think we do know from the research is that when there is compensatory gain, marbling is lost and is difficult to regain. And we've seen that in studies in the United States where calves have been, you know, weaned, and then they've been on a very low plane of nutrition, and we divide, you know, some get high nutrition, some get low, and it's clear that a period of compensatory gain is going to really hurt marbling, and that is going to be the last thing to come back. But I think with the right management, consistency, and then you have to also think about things like health. You know, bad health wrecks marbling. It wrecks everything. you just don't notice it. You notice when the calf is smaller. You notice when the calf is thin. You don't see the marbling, but it's lost too.
Muchas gracias por la presentación. Primero quiero hacer un comentario. En el caso específico de ganado lechero, el impacto de la selección genómica fue el más importante por una reducción de intervalo de generaciones por un factor de casi 3, y lo cual permite corregir más rápidamente las decisiones erróneas de selección y cambiar los objetivos del mejoramiento. ¿Eso también es válido en vacunos de carne? ¿El intervalo de generaciones es más importante que el incremento de la precisión o es más balanceada la situación? No sé si me explico. Gracias.
Thank you, Dr. Gianola. And maybe you have the calculations. Maybe we should work those out. I think that is a good question. Certainly in dairy, because of the turning of generations and the short, relatively short productive life of the cow, that there is more opportunity. And in beef, it depends. And some operations turn generations more rapidly than others. And there are some environments where nature turns the generations perhaps more. And I think there is more power, more benefit when the generations are turned more rapidly. But I think there's economic work that shows that even in beef with a longer sort of time horizon, a longer generation interval, that when traits that are otherwise unmeasured or difficult to measure have real economic value, that you can see sufficient improvement in those traits to justify the cost of the testing and the use of the information. But it really, we see now in the United States, as you know, some testing, not just of seed stock, but of commercial heifers. And in that case, I think it's a little more difficult to justify the cost because it depends too on how are you practicing the selection. If you were going to keep 2/3 of the heifers regardless, then you're not changing a lot of decisions with genomic testing. But if you're in a situation as a Angus seed stock breeder and you're going to use, for example, embryo transfer, and you can identify a superior female and use her in genomic tests in embryo transfer and see that benefit, then I think that's a case where the return can be significant. I also think that in beef where we are, whether you're selecting AI sires or selecting natural service sires, that you're selecting among many herds and you're selecting just a few individuals that will generate a significant number of progeny, that having that information, that accuracy, I think the genomics would justify having the additional information, particularly when the bulls are otherwise, there's no progeny testing. I think that we see pretty significant differences between full siblings, and I think that difference reflects or results in differences in profitability, and so I think in that case, not as strong as dairy, but I think still well worthwhile.
Buenas noches, doctor, mucho gusto, muchas gracias, muy interesante la charla. No, una consulta, simplemente, ¿qué impacto le vería y qué posibilidades habría en la integración del banco genético uruguayo con otros bancos de la región y eventualmente con otros bancos de Norteamérica?
Yes, I think that we are more and more global all the time. We see in North America and more cattle being used from other countries, and South America would be included in that. And I think you do, as I mentioned, I think you have a unique opportunity because you are in a slightly different system and you are evaluating cattle in a slightly different production system. And I think when cattle come to the top in that system, then that shows that they have potential to work in similar systems elsewhere. And that you are progeny testing more Angus bulls in grass-fed conditions than we are in the United States. We have some forage-based testing, but in terms of progeny testing, those sort of things, I think that you will learn some things. And I think that you will identify some genetics that work very well in that system. And I think that we have some similar systems, and I think we will have more similar systems. Now, of course, there's all the trade and the health and all those sort of things, and I'm not an expert in any of those things. But I think that there are already, I know farmers that are focusing on grass-fed beef, and you see it in restaurants. You see, that is not a foreign term in my country. It is very common, more for consumers probably than for producers. But it is, for consumers see it, they ask for it, they want to know more about it, they pay more for it. And as I know ranchers that are moving into those systems, and when they are looking for genetics that work there, they look south. And I think that will continue. And I think they're right to do so.
Bueno, vamos a estar culminando por acá. Disculpas a los que quedaron con ganas de preguntar, pero tenemos el remate. Queremos agradecerle nuevamente a Genexa y a Neogen por el apoyo para esta conferencia. También queremos destacar que este año la prueba del SER está cumpliendo 30 años y ya hemos conversado con Dan para que retorne al Uruguay en agosto para hacer una jornada junto al equipo técnico de línea importante para la raza, para celebrar ese aniversario y seguir tratando estos temas. También decirles que vamos a seguir continuando el trabajo con Dan en la comisión técnica, ya lo consideramos parte del equipo de Angus Uruguay, así que todo este conocimiento junto al de INIA y junto a los técnicos de Angus van a seguir estando cerca del Angus uruguayo, que creo lo jerarquiza, así que estamos muy contentos con eso. Muchísimas gracias, Dan, y esperemos tenerte pronto por aquí. Muchas gracias.